So one of the things I'm trying to place with your research is it seems like it has a large number of replication themes in it. Because when I saw that you're delivering these published clinical metrics to clinicians so they can test them out in the real world, and then also your work with taking these high dimensional data sets, reducing them to these I guess identifying these low dimensional structures, and then you know again trying to infer uh, clinical value from them. um, it seems like you're hitting on a large number of sort of like replication themes, but it also didn't really fit cleanly into, I guess, what these like stereotypical replication research. So I guess my question for you, because the conversation I wanted to have is sort of like, where do you see your research actually fitting into the work of the replication work?
Yeah, thanks. So in my own definition, the replication is when you have another study that studies the same effect and it finds the same result, broadly speaking. And I think for that to happen, at a minimum, the original study has to be reproducible. So what I mean by that, if you take exactly the same data, can you repeat the analysis in exactly the same way as the original study and get exactly the same conclusion as the original study? Because if you cannot do that, then it doesn't, like, it's even harder to replicate.
Mm-hmm. Yeah, that's a good distinction to make. Can you go into that a bit more?
Yeah, I think in my research, I feel like at a minimum, to make sure that the replication standards are really high. And it is actually my opinion that it's really, really hard to reproduce someone's work, even if you don't do a new study, even if you're like just trying to get the same data or process it exactly the same way. And because our statistical pipelines are increasingly more and more complex, there's so many choices that are being made that if you don't make exactly the same choices, or if you don't know what those choices are, you wouldn't get exactly the same answers. And how do we document that? How do we make it so that someone else who, let's say, reads our paper, uses our software, can arrive at the same exact result? So to me, this is reproducibility. Exactly the same data set, exactly the same analysis, being able to get the same result. Now, where the replication, I think, comes into that is, in a way, how robust are our analysis? So, for example, I did a lot of work on variable selection using lasso-based methods for high-dimensional problems. And there are various ways in which you can select the T parameter of those methods and try to analyze the variable selection performance. And I think there is a lot of value in those areas of methods using subsampling-based methods or bootstrap-based methods, where you purposefully do various perturbations to your data to see what are the patterns or what are the variables that are being selected most consistently. Because this way, I feel like you have a higher chance of actually replicating that later on, because this minor perturbation is not going to change the result. So I think, again, to answer your question, there's sort of two stages to the replication. The first stage, I think, a minimal requirement is that the original analysis, data collection, data processing is completely reproducible. And then you can have a completely garbage analysis that is completely reproducible, right? So that's not necessarily a guarantee that it's replicable. I think from there, to go into the replication, you have to build some mechanisms, some robustness checks in your analysis of assessing various things, like if you perturb your data a little bit, or if you perturb your tuning parameter a little bit, do you still get the same result? And of course, it goes without saying, it's if your original data is biased or garbage, whether you do some sampling or whatever fancy method, it's not going to be replicable. If someone forged the data, you're not going to be able to replicate that.
Yeah. Can we just sort of like hit a few of the like points that you made along the way? Because some of these are interesting with so for example, when you're looking at variable selection, so the idea is that if you are churning over your data and varying it in certain ways, and bootstrapping, for example, and the variables that you select remain the same, where does that sort of fall on the replicability continuum? Because there's like, did you select the same variables, and also did those variables still have the same correlational structure that they did before? Are they is equally predictive? So where is it sort of like a continuum on in that regard, or what's your call?
So to me, doing something like subsampling or bootstrap and only identifying variables that are consistently selected for those, rather than the variables that are the most predictive of the trained data, statistically, to me, that's a safeguard of against overfitting. And again, from statistical perspective, if you overfit, that means your results are not generalizable or much less generalizable to the new testing data. The whole idea of replication is someone collecting new data, having a new experiment, and seeing whether they can find the same effect. So this is where statistically, if you overfit, the theory tells us you would not be expected to replicate that, because overfitting by definition means it's not generalizable to other data sets. So that's where I feel like some of the statistical techniques that guard you against overfitting also help you with replicability down the line.
Yeah.
And just to give you like one example, and I'm sure that that's not, I've seen some talks where people use it in the regression context too. But like if let's say we take variable selection with LASSO, right, a very popular method. One way you can do it, and I think it's still the most popular way to do it, is to run cross-validation. You can run it based on cross-validation, see what's the model that you fit based on that, and report that model. And there's nothing wrong with that, and the cross-validation for selection of tuning parameter already gives you some robustness against overfitting. But if you want to go a little bit further, what you can actually do is you can take subsamples of your data, do cross-validation based on those, fit those models, have a whole range of models for each of the subsamples that you take, and then look at what are the variables that are most consistent. And that's actually very closely to this idea of stability selection in statistics. And so I think fundamentally, those types of data perturbation approaches do help you with reproducibility in a sense that they try to guard against perturbation of the data that can give you a completely different conclusions. That, in my mind, is again different from reproducibility, where the whole goal is to just make sense of whatever you did. Like we're not judging whether it's smart or bad, but that it could be reproduced and exactly the same answer could be obtained. And I think both of those areas, reproducing the answer exactly, replicating the answer exactly, and making sure that your analysis is not so sensitive that it couldn't generalize to anything new, both of those needs to be addressed to make something actually replicable.
Yeah, no, that makes a lot of sense. It actually reminds me of back when I was doing a bit more of my Bayesian optimization work on patient vital signs. And so an interesting thing that sort of flies in the face of traditionally what we think of in the machine learning community is like, you have your training set, and then obviously your test set, you're going to get so much, like you're always going to have a decrease in performance in your predictability. And for my work, what I did was I actually I tuned a secondary sort of a Gaussian process to help optimize and search for optimal parameters over optimal parameterizations for time series prediction. And so instead of saying, basically I had this one parameter, what I'm saying is basically I have this system that essentially cleans the data. It then optimizes the parameters for predictive accuracy in a more generalized way. And one of the interesting results was that the way when I had my training set on which I developed these things versus my test set, I'm trying to be very clear with those because obviously, I think the definition of training or test versus validation set obviously changes between the machine learning community and the clinical informatics community. That's a quick side note, but
yes,
yeah, and I'm stepping very carefully. But yeah, one of the interesting things was that actually my test set performance was actually better than my training set performance. And because it's essentially the method, it was a method of regularization, but it wasn't so rigid and ham-fisted that it actually generalized so well that it just so happened that it found better patients, like it found the patients in the test set much easier to regularize against. So part of it might have been that I was, choosing very tough patients to train on, and then yeah, you get better results. So that definitely does ring true to me as something that is of use. One of the things, since you've worked on, sort of the high dimensional data sets and low dimensional structures within them, is there an issue with sort of you can choose either replicability or reproducibility when you're essentially trying to extract low dimensional structures from your data?
I think there are tons of issues,
Yeah.
and I think this is actually one of the passion for reproducibility that I have actually comes from my own frustration as a graduate student when I would read the papers and I would find that they used a public data set and they applied their method and they report, the error rates and whatnot. And I would try to do exactly the same thing.
Mm-hmm.
And I just don't get the same numbers.
Mm-hmm.
I just don't. And I'm like, is there like some data processing that I'm missing? Is there like some slightly different data set? Is there some tuning parameter choice that I just don't know about and what I'm doing is different? And it was just like extremely frustrating. And I think at the time I made like a vow to myself that whenever I tried to describe things, which I'm sure I have failed probably more than once, but try to make sure that when my simulations are described, you can like exactly reproduce what's in that. I think part of the problem is that there is not a lot of incentive in the profession to actually spend time making it so.
Yeah,
because it's a hard work.
Yeah. I just make the stronger statement that there's nigh on zero incentive to do that. And unless you are going to actually turn that into a research field of itself, which, people have been doing. So unless you're literally going to focus on that as your actual statistical research field, I don't see that there's any huge reward.
You can make a difference individually.
You can make a difference. Yeah.
I'm not sure if I should share that, but I guess it's more personal. So I would say like I'm an associate editor for the Journal of Computational and Graphical Statistics. And so because it's a computational journal, we expect, of course, that there will be software coming with the submissions.
Mm-hmm.
And there is pretty large incentive, or at least there's a lot of encouragement for associate editors and for the reviewers to look whether that software is actually there. And we specifically tell for the papers that are close to acceptance that we're going to run it.
Mm-hmm.
And we are going to run it as is.
Mm-hmm.
And if it doesn't run, you have to fix that.
Right.
So I think in that respect, if you care and I care, it's been good to be able to provide incentive for someone to make the code more usable, because ultimately, I think if you have a well-documented code that just runs and is reproducible, that means that more people will use your method, that it will be more accessible. But it is a time investment. It's a huge time investment to make your code written that well and documented well and run that well, and there's still not enough incentives for that.
What do you think? So when someone is trying to essentially, maybe we'll just use your own work for an example, where there's more to just reproducing something than just making sure other researchers have it available. You've actually made sure that clinicians have your work available, which to me feels like that's like just putting it out there in the wild, which is where ideas and metrics can be very rigorously tested.
Yes. And actually, there were some really interesting challenges that came up with that particular work. So I assume you're referring to the work on glucose metrics,
Yes.
calculating them from continuous glucose monitors. So when we did that, so first of all, we wanted to have a place to calculate them all.
Mm-hmm.
That was kind of the original motivation. And so you have to go through the literature to first find, the definition of those metrics. And this is where, for statisticians, something kind of frustrating has happened. So most of those metrics are in the clinical literature, and some of them like, okay, it's the mean, right? Unambiguous. I know what is the mean.
Mm-hmm.
But then there will be some where you would have like slight discrepancies in formulas,
Mm-hmm.
or they will be described in words that sort of, make sense. But if you start coding and trying to implement them, there are ambiguities.
Mm-hmm.
And in particular, for example, there's this one metric that's called MAGE, or mean amplitude of glycemic excursions.
Mm-hmm.
So the idea is that you look at the glucose profile, you visually look for the hills, so you look for the peaks in the glucose, which will be like a spike of glucose due to meal.
Mm-hmm.
And literally what you want is to be able to calculate the height of that spike and then pick up the heights that are large enough in some sense and take the average.
Mm-hmm.
And when I explain it like this to you, it kind of makes sense. You want to see what's the average size of the spike. Larger someone spikes, the worse it is for them. So great. Now try to do this algorithmically.
Yeah.
And you can start seeing that there's going to be a lot of issues in really trying to computerize that description. And there's actually been a study in diabetes literature where they compared a couple of calculators of this metric. They give different answers, and the study conclusion was, oh, maybe you shouldn't use this metric. And my conclusion is completely opposite. You should just figure out exactly how the metric is calculated.
Yeah. So like I'm just like off the top of my head when I was thinking about how to do this. So basically I'm gonna use my wavy hands. But I actually have a pen and paper right here that we can use if necessary. But I was basically thinking it's like, okay, as it comes and reaches its peak, so and then it decreases down. So one, you can figure out the peak. Just using a derivative. The question is like, well, if it drops a little bit and then comes back up and then drops back down, it's like, is that a second peak or
a lot? And plus, you have to remember that those glucose measurements, they're not absolute glucose values, right? Mm-hmm. There's a measurement error. So you can do like this little tiny spike and then up, or you can do two peaks. Do you combine them together? Mm-hmm. Do you not? So actually, since we're on this topic, a little bit of advertising, but I have an undergraduate student, Nathaniel, who figured out a new algorithm where you do some pre-smoothing, which allows you to kind of identify those peaks less ambiguously.
Yeah.
And another undergraduate student, Nan, he actually did manual calculations because, human eye, we're very good when you give us like a picture. Should this be a real peak? Should this not be a real peak? Human eye is really good at pattern recognition.
Absolutely, yes.
And we did this because that is the gold standard. That is the original definition, manual calculation. And it's really frustrating as a statistician that all of these calculators that I see, either they never actually compared to the manual calculation, or they did a comparison, but the data is not available, nor are they manual calculations. So I cannot reproduce it.
Yeah,
so to our nice discussion.
Yeah, it actually reminds me of, I think this was the Christmas break of 2016, where I went through and manually annotated artifacts across several dozen. So basically it was 2 days per patient, and I did about 40 patients. And just like, and I developed a script that would bring up that actually bring up the plot in the UI and let me click around and manually identify these things. And it seems like what your student did is absolutely the perfect thing to do. One, it's like you have a problem and you just sweat it out. Like the solution to this problem is you just work and go.
Most problems have that solution.
Yeah, but like you could imagine that say you wanted to use the so some type of like averaging system to remove the noise from the peaks. Well, the
That's
question is
actually
like,
what we're doing. We're
yeah,
doing averaging.
yeah, and then also the question is like, okay, well, what parameters do you use for that smoothing algorithm? Because now you're trying to process it through a smoothing algorithm. It's like, well, that's an empirical question as well. So how do we deal with that?
Right.
It's like, well, let's manually annotate what are the peaks, and then we can basically tune the rest of the algorithm to identify the peaks. Upon identifying the peaks, then you can proceed to the next step of actually averaging across these, these peak events. And so it's one of those, again, it gets that thing that we've talked about before, where these vital sign problems, you can call them problems, challenges, what you will. It's an infinitely deep technical issue because there's always something that you can do to tune something or to make it better. And you pass an algorithm through another algorithm and things like that. So yeah, I those two students you mentioned are probably going to have zero problem getting into a very good doctoral program if they are interested.
Oh, this
Because,
is the amazing thing. One of them is a freshman.
Jesus, sorry. Yeah, that is. Oh man, it's like, is he available? 'Cause
I
yeah, no,
hope he likes to work with me for a little bit longer.
yeah, no, I mean, 'cause you can imagine that, like, the value. We'll go off topic for a second because I think this is important. The value of someone basically finding something that they're good at and working on it through the duration of their undergraduate program. I think that that's just a really amazing experience, and that's super impressive.
Well, and I think in this case, we had it really helps when you have a very real problem.
Hmm.
And
Yes.
this
Oh, absolutely. Yeah.
case, like there is this original metric definition, which essentially is provided in words, like I sort of given to you.
Hmm.
And then there have been different computer programs created to try to calculate it. And out of at least 4 or 5, only one of them actually said in the paper that they tried to compare against manual calculations. One said they look visually and the result made sense, did the right thing.
Hmm.
One said they did a lot of manual calculations to cross compare. None of those are available for the community. And the others just did the algorithm.
Hmm.
And so you have like reproducibility, replication, accuracy. And then, someone does a comparison of them and says, okay, they have a poor agreement, not surprisingly.
Hmm.
But those two agree. So this suggests that that must be the right one, which again, I have an issue with because two people can do the same thing wrongly and agree. That
Hmm.
doesn't necessarily mean that that's the truth. And so I think there was a lot of like, okay, we need to have a gold standard. We need to make sure that when we establish it, because manual calculations, are prone to error. They could be
Hmm.
very subjective.
Yeah.
So the only way I feel like you can actually claim that it's accurate is if you actually provide the numbers and the data to other researchers. So someone can critique your manual calculation.
Hmm.
You can at least have a discussion on that.
Hmm.
And I think if you don't have that, like how can you even hope to have something replicable or reproducible?
Yeah. No, that is a good point. And again, this I think this is sort of the interesting thing because when we're talking about um, reproducibility and replicability, that there are a lot of messy elements. Like, I mean, I think the more traditional conversation about reproducibility is very interesting in its own right. Because obviously, we're going to be covering that in a number of interviews. But yeah, just the number of like specific elements that make things messy on this issue, I think it is very interesting. And of course, there is the issue of incentives, like how rigorously, how severely are you going to test your methods? Are you going to, and even like one issue is like there's probably plenty of researchers who are more than happy to really test the bounds of their own methods and really rigorously figure out where things fall apart. But the challenge is that by doing that effectively, you're opening yourself up to attack from the
Yeah.
reviewer community. So what is good science is actually in many ways discouraged because essentially if you're publishing what's left, it's like unless it can fit into a future research section of your paper, then don't bring up any weaknesses of your work. I think that's unfortunate as well.
No, I completely agree that in general, we're doing better in some ways, but I think not good enough in terms of incentives. Like, based on my personal experience, and maybe it's just me, but for me, actually cleaning the data and the code and making repository before the paper submission
Hmm.
is one of the most time intensive tasks.
Absolutely, yeah.
Because like you have to clean through all of, like pursue, you've done all the, dead loops that you took, figure out what was the clean final version and how you actually arrived at it, and make it so that someone else can, in my case, clone your GitHub repository,
Hmm.
run it, and get the same result on their machine.
Hmm.
And that extra time means that you're going to delay your paper submission, you're going to sit longer on a paper, and you're going to sit longer on it at the expense of another paper that you could have written.
Hmm.
And so it's a lot of investment without necessarily having a lot of immediate return.
Yeah. And honestly, I mean, in whatever future return there is a little bit more in the abstract, and it might not actually be a return. So, like, there is an element here where there's a significant opportunity cost to doing good science as opposed to mediocre publishable science, and that opportunity cost, unfortunately, is inflicted on generally the most scientifically acute, so to say, people. So, as in the people who are most rigorous about their science, the burden of rigorous science is placed most heavily on them. Um, Unless like you're just a master of the game and you have, thousands of, postdocs and things like that to work on your research. But there's an issue there where I think that's underappreciated, where it's not only that is this a burden, but it's a burden placed precisely on the people who have the highest opportunity cost for scientific endeavors.
Yeah.
That's probably an idea that needs to be fleshed out a bit, but I'm not.
But I
I'm
mean,
not.
we are
Yeah.
the people who shape that. And I
Hmm.
mean, you can talk about how there should be an institutional change, but ultimately we are the people that shape that. So if as a reviewer, when you review papers, if you as a reviewer do not uh, put critique on the software, on the
Hmm.
reproducibility, instead put the critique, on your method doesn't beat the other methods all the time,
Yeah.
that's what's shaping that ultimately.
Yeah. Battle of the. I call it battle of the algorithm, and like they are. I think that they are my least favorite part of my favorite aspect of research. So like obviously I love medical informatics and medical machine learning, but the battle of the algorithms type papers I think should probably are. I'll just be aggressive and say our field is pretty much better off without them. Like most of them aren't actually making any real scientific progress, so it's not like they're actually discovering anything really. Especially because when you're so busy, when these papers, just to sort of give my own highly opinionated bit on them, it's like um, they are only focused on presenting recently published methods. So it's essentially you're only selecting based on whether methods are recently published, not if they're applicable to, for example, the mechanistic aspects of biology, any like underlying correlational structures of the data. It's usually they're relegated to hyper recent algorithms, and there's no explanation put into why this algorithm actually matches to the data very well. Furthermore, there's nothing telling you like why we would choose this algorithm over another, and then they also become so fixated on just the comparison that there's no scientific discovery element. So it's not saying this algorithm discovered this novel structure and we can tell something about this clinically or tell something about this biologically. It's you know new algorithm beats old algorithm, future work, conclusions done. And
Yeah.
I yeah.
And I'm a little bit more optimistic in that respect. I
Okay.
don't I do think there is a value, and I actually like especially that in the machine learning community, at least there's UCI machine learning repository, right?
Hmm.
So at least in that community, when someone tells you they took this data set you can access exactly the same data set,
Mm-hmm.
and many people can access that data set, and you all can have your method or your algorithm compared on that. From scientific perspective, I agree that just running your algorithm on 10 data sets and saying which one classifies best does not give you any value to the scientific problem that you may be interested in. But I do feel that there is a place for that type of research, and there is a value in at least knowing across like a large benchmarks what's the relative performance.
Mm-hmm.
What I think, in my opinion, the issue is that somehow we value that much more
Yeah.
than a simpler method with a deeper understanding of the problem and corresponding insight.
Yeah.
And I think that's kind of where the issue is.
Yeah.
It's not that the other one is not having any value, it's of how much value we placed on that.
Yeah, well, I think there's a difference. Like, obviously, no one's going to be throwing out benchmark comparator papers because they're just too valuable. They get a lot done, and what would be nice is if there are in fact more benchmark data sets by which people could do these types of things. Especially because as algorithms become a bit more narrow focused, they might actually just be optimal in certain settings. And so by having more benchmark data sets, you can actually say this data set or this algorithm is sort of keyed into this setting. I guess my critique of the battle of the algorithms when it comes to applied work, because I'm not sure if benchmarks really count as applied work. They might not. People can send me their hate mail for saying that. But like the idea is like it's not applied to what might be a real problem. And when you are applying it to a particular problem, I think personally, I only like to judge it in the context of that problem. I know that's not a profound statement, but it's still the idea.
I think it has a value though, because different fields sometimes have focus on different problems.
Mm-hmm.
And even though mathematically the problems may sound the same way, like both have a matrix sample size of this and I don't know, this many variables, the fact that they're coming from different domains inherently potentially change quite a bit what the characteristics are and also what the person may want the scientist to get out of this data. So to give you an example, in my work, I actually did a lot of classification methods based on extensions on discriminant analysis. And the typical criticism that I always get is, why don't you do random forests or kernel SVMs or something like that? And, if you go to some imaging data or text data, I bet those work much better because they have nonlinear structures. They tend to have larger sample size, not as many features. On data coming from genetics, where I have been applying my methods, in a couple of papers, I actually did comparison. And it's not better. Sometimes it's actually even worse. And what's most importantly, I don't know how to interpret it. I cannot easily extract what are potential biological pathways that may be of interest, or what are the variables that, again, I feel much more confident through the subsampling bootstrapping that are actually important. And yes, I may not get sometimes even as good of a classification, but I get better, what I would argue is a better insight and interpretability of what actually matters. And if you are, I don't know, a recommender system and you're just trying to predict which movies someone would like to watch, I don't know, maybe you really don't care what goes under the hood and what makes someone prefer this movie over the other. You really just want to predict. But I think in medicine and biology, we really want to kind of understand what's happening under the hood. And that's where, there are different value systems, essentially.
Yeah, no, I mean, well, there's plenty of evidence to support what you said. For example, in biology, the fact is we don't just have correlation based models of our of the phenomena that we're interested in. We also have like mechanistic models of them. So something completely different from what I consider the most traditional statistical or machine learning models, where we actually say like, let's define some basic believable rules about these mechanisms and deduce what type of system arrives from that. Simple things being, for example, like interactions between cells, or the elasticity of a blood vessel as blood is pumped through it, and that's the new model. And so yeah, there's plenty of in biology. There are many ways that people are attacking, trying to get at what's under the hood.
Yes.
Especially because that's where like our future is. Like we can't build much farther if we don't figure out better what's under the hood and how these things interact.
Yeah, and I think there is a value. I mean, the whole value of research that we explore and we try different things. There is a lot of value in, kernel-based methods or random forest-based methods. There's a lot of work that has been done, and this continues to be done in trying to make them more interpretable. So by no means say that simpler models is better, but I think the value of research and in generally scientific endeavors is that we acknowledge the value of pursuit and the value of exploration. And I think sometimes we're so fixated on the productivity metrics that it's detrimental to the pursuit, it's detrimental to the replication, it's detrimental to reproducibility.
Yeah, actually, it's funny that you're mentioning metrics, because in the back of my head I was thinking, the one other critique that I want to have is like, most of these performance metrics can be gamed in some way. Yeah, especially like if it's actually, here's a basic irony that the people who tend to just want to be publishing and will essentially would be happiest to game metrics, they never learn their data sets well enough to really figure out how to game those metrics. Whereas like, if you're trying to do good solid research and you spend time critiquing methods or metrics and thinking like, well, is this metric actually a true representation of what the sort of clinical outcome would be? I found the one where this was in a data set that I've looked at extensively, but it's basically on early warning. And one of the things that I noticed is that effectively the metric was gameable if you're looking at sort of these rates of false positive. And so like the metric was it was like super duper gameable. The only thing you had to do is essentially just keep upping your prediction rate. And you would do better. And so I took that example. I took a few other examples. They're a bit weaker. But like I collated them into this story about, it's like, here are like 5 clinical metrics that are super gameable. Like they're common and they're gameable. And here's precisely how you would game them to basically make anything work. And it's like no one liked that. No one liked that at all. Like trying to get that published was well, it was not a success story. But actually, now that I was actually thinking that now, so I'm not sure if I told you this, but I'm working on the editorial section. So I was added to the editorial board of the Journal of Data Science, and one of the things I want to do for our editorial section is I'm going to take that and I'm going to publish that.
And you're going to put that.
Yeah, it's like, so yeah, there's a bit of corruption because obviously I'm publishing in my own editorial section, but I think it's useful. Like, yeah.
I mean, in general, I always have an issue if it's just like numeric metrics. I think we like to have a number so we can just compare two numbers, and it's a direct comparison. It's easy. One number is larger than the other, and we're done. But that's not how life works. And I mean, we keep trying to do it with SATs and with TREs and with GPAs. And it's just like, but that's not really predictive of performance or success. And science reduced to a number is not a good science. We keep trying to do that. I don't know why. Yeah,
it actually, where was I? That reminded me of something, but now I'm forgetting it. Yeah, sorry, maybe I tried to reduce my thought to a number and it just disappeared.
No, it's fine.
But I mean, it's like we like the sort of the idea of like the comparability aspect. Making no attempt to reduce something to a number. Oh yeah, I remember where I was going to go. Making no attempt to reduce something to a number obviously leads to its own sort of pathological areas.
No numbers at all. That's a whole other.
Yeah, but it's like the saddle point isn't like a razor thin saddle point on this. It's like you don't go crazy trying to reduce things to numbers. You don't also just totally ignore the numbers. So like obviously, the p-value statement on from was it the some psychological journal where they're totally not going to look at those things
Yeah.
anymore. But at the same time, like so, like there's one side, and at the same time, you can realize as well there are plenty of hypothesis tests that you could perform. Like you could game a hypothesis
Oh,
test quite
yeah,
easily. It's like
absolutely.
choose you have imagine you have bimodal or trimodal data. And it's like, well, let me just try to do a t-test and I can probably manage to game some significant outcome on that. Things like that where it's just the actual hypothesis and the model is not actually representative of the underlying.
Well, and that actually brings back our original discussion of replicability. A
Mhm.
lot of the issues of replicability also arise as a result of gaming that happens
Mhm.
either consciously or subconsciously. If you conduct a study with the determination that this is what you're going to find, then you're going to work hard to find it.
Mhm.
And that's created a lot of issues, unfortunately. And I think um, that's why a lot of the analysis steps is really important, I think, to reproduce. Because if someone tells you that, I don't know, they had these 5 subjects that they removed for the reasons that don't seem very appealing, then at
Mhm.
least you can have some evidence or some inkling that maybe something was gamed here.
Mhm.
Or at least you can have, an objective discussion. Is this biasing the results? Is this not biasing the results? But if it's just, not reported, nowhere to be found, then you have no clue at all.
Mhm.
And we all do, I'm sure, like I remove subjects sometimes for various reasons. And I think this is where, to make sure that you're not subconsciously biasing your results, you should at least report it and
Mhm.
make it so clear that someone else can hopefully find it.
Yeah. Actually, I remember that I had an appendix section once. Apparently this is just going to turn into a monologue on my grievances, but like I just like my appendix sections are like long because basically when you're trying to do this thing, we're saying, okay, here's how we select. We have a population of patients on a ward, and we're selecting from these patients for this reason, usually because of some form of clinical acuity or another sort of confounding event where they would just not be they would not be appropriate for this type of analysis, and so you remove those and they say, okay, now for each of these patients I have this data cleaning method that runs through it, and then at each time point then I fit the model going this way, and then I have this algorithm monitoring over the top of it. And so like I put some of those big things in there once, and unfortunately, like I don't know why, because it's not like there should be any real limit to an appendix section, but somebody wanted me to replace that once with like a subsequent battle of the algorithms issue. So it's like, why did you compare this to SVMs? And that like it's like
And they
what
wanted you to take that out?
yeah, like as if time, or sorry, as if space was a problem in this appendix of an electronic journal. Yeah, no, it did not make
Oh
any
my
sense.
goodness.
Yeah, and it's one of those things. It's like, well, I could now have just wasted several months of my time, or I can just comply. And if people are really interested, they could check out my doctoral work or some of my other subsequent work where I describe these things in a bit more
That is
detail.
so incredibly sad. I've
I,
never
I
heard of that happen, and
yeah,
that is super sad.
I think it's like one of those things where it's like aiming for parsimony, where it's just like it's like if we make this, it's like we got to keep this thing tight. It's like no, this is the appendix. Like this is where you don't keep things tight.
No,
Yeah.
I mean, I completely agree that. I mean, I always tell it to my own students that within the main manuscript, you kind of want to keep the narrative of the story,
Hmm.
but you want absolutely to make sure that you have enough simulation details that someone can reproduce it and enough details on data processing.
Hmm.
But if those become cumbersome or too large, you can sort of do the big highlights in the main manuscript, but put those details in the supplement,
Hmm.
because you don't want another student like, I mean, I always think of myself in grad school coming to that paper and like swearing to the authors so they can
Hmm.
figure out how to reproduce the simulation study, and but I've never heard someone trying to take it out, asking explicitly to take out from supplement.
Yeah, I
I
mean,
think
it also has the element where, as you know, like a lot of journals, they basically have like the two strikes rule, where you have essentially, you can basically have one major edit, one minor edit, and then you must publish. So effectively, it doesn't actually allow for very much time to like have discourse or strategy as in like, well, I'd like to leave this in. Can I just do that? Like there's no time where the only thing you can do is either rebut and send in a new publication. Sorry, send in the revised draft. So you can either basically, there's no time to actually have a conversation with the person and say, is this actually what you want, or is this sufficient? Is this actually what you want, or is this sufficient? And you sort of have this like one-shot chance of resolving this issue, or alternatively, the person could just say, too many major corrections, reject. And so there's a weird contraption to send your work through where like there's no time just to have a direct conversation.
But I think this is another problem of the system, because fundamentally we want papers to be published so much that when we're in the process of revisions and reviewers ask us something that we don't even necessarily agree with, there is like this push in some sense to do whatever it is to make them happy.
Yeah.
Because we want the paper to be in. And I'm not saying like you wouldn't say no if it was like a completely like I never seen a request that was, completely off. Like do something that is wrong. But
I've seen plenty of review requests, more on the side of when I am one of the reviewers and I'm reading some of the other reviewer things, reviewer comments, like, and thinking direct is like, no, that's going to make the paper so much worse. So we're just like just off-topic stuff where it feels like they're just wanting to say something. But I think that part of this would be if journal editors, the head honcho, the person in charge, actually just took a stronger hand in some of these things and said, like, this is not a reasonable request from the reviewer. This is a better paper as it is. But, obviously there's not much incentive to do that because you're trying to not annoy your reviewers because obviously they're just donating their time. Or they're donating their
editors,
time.
They're donating their time. Most of the time, editors don't get anything.
Right. Well, they get credit for being an editor as opposed to being a nameless reviewer.
Tell me, what do you do with that?
Yeah, fair enough. Yeah. Probably about the same thing. Yeah, but
obviously we do it for the science, and that's why we're here. We write papers for the science. We review papers for the science. That's what we do it for. But I do want to kind of come back to this point because I think ultimately it's not about what we're expecting from the editors or department heads. That's a conversation that could happen, but I think the biggest change that we can do is individually, when we are reviewing paper, are we paying attention to how reproducible and replicable potentially the study is based on the methodology? Are we asking for another comparison to another algorithm? And there's nothing wrong about asking for another comparison to another algorithm, but if we're not individually in making this claim that that's important, then it will never become important.
Yeah, I think that's fair. And especially like, I guess one other thing is that I think there needs to be a validation or at least some support for why a particular algorithm warrants comparison. So, it can't just be that the age of the algorithm, the age of the algorithm's original publication date cannot be the actual metric by which we decide which comparators enter. It should be something where you have to understand, here's the nature of the data. Here is the sort of dynamics that this algorithm is adept to pick up and model and make use of, exploit, if you will. And that has to be along the lines of reasoning, not just can you slap the newest model on this data? And
but I guess there's this tiny silver lining here, and the silver lining is that I think that's the favorite request. I'm guilty myself as a reviewer. I definitely asked for additional algorithms for comparison. If the additional algorithms do not have a nice software that is easy to reproduce and run, I'm not going to compare with it. Just period. And as a editor and a reviewer when the authors provided me such response, and that was actually the case, I think that's totally valid.
Mm-hmm.
So in a way, if you don't have software for your author, then I think you have to accept that someone may not be able to compare with it, nor should they be putting the responsibility on implementing your algorithm.
Mm-hmm. Yeah, fair enough. I mean, yeah, I think we've both had similar issues where, especially in a lot of clinical informatics research, where you try to reproduce. I'm not sure if it's especially there. It's just the only one I know better
I
than
think
most.
it's more there than in the machine learning, because again, in machine learning studies, a lot of times it's like, okay, we took this data set from UCI, and at least there is a very nice simplicity in it. I know exactly what is the data set.
Mm-hmm.
A lot of times, for various reasons, some studies are more recent and the data is protected. I kind of understand that too. But there are other times, like for example, there is data publicly available from the Atlas project.
Mm-hmm.
However, the data, typically as publicly available, is processed in various ways.
Mm-hmm.
And in my experience, that is typically not described adequately.
Mm-hmm. What do you think about so what about cases where effectively a company has some proprietary data set, but obviously the algorithm itself isn't proprietary, and they're just trying to show the world that this was a thing that worked. And there's many reasons why a company might want to publish, or people within a company might want to publish, including just some things that are just interesting. What's your sort of like general gut feeling, like off the top of your head about that? Is it just
my personal opinionated take on it is that
Mhm.
they have to provide at least one other data set that people can access.
Okay. And so is that for if they're trying to show that an algorithm performs well in a certain scenario, or alternatively for the sort of publication where they're just trying to show that this problem is solvable in some way?
I think the second is a little bit less defined,
Yeah.
but the first one definitely. If
First
you're
one seems
developing a
clear.
new method, that's a no-brainer.
Mhm.
And I actually did this thing for one of my papers where I created a simulated data set
Mhm.
with the characteristics that were very similar to the real.
Mhm.
And then at least anyone interested can apply it to the simulated data set that looks similar to real, but not exactly real. So I think that's also a viable option.
Yeah, that's a good idea.
But if you don't have anything, you just have one proprietary data set and that's it. I
Mhm.
hate papers like that.
Okay.
I mean, I'm sure there are exceptions, but I tend to have inherent distrust in the results
Mhm.
when there is absolutely no way for me to anyhow touch it or try it or validate it.
So when you say distrust in the results, do you mean that you distrust that even the result exists because there's no way to verify it, or simply that it doesn't seem like this result would actually be particularly useful in other scenarios because there's too much that's ambiguous? Like it could be both, I guess, but
I think I distrust a little bit the rigor of the analysis
Mhm.
just because I cannot verify it or reproduce it. So essentially, I have to inherently trust that whatever is written and said about the data is actually true.
Mhm.
And I feel like if we have to put that kind of trust in a lot of different companies, that's a dangerous path to go. So I do not want to do that kind of trust or be in a position where I have to exercise that kind of trust.
Okay.
And I know this is probably a very orthodox or unorthodox opinion, depending on how you feel. But
Mhm.
personally, I feel there should be either simulated data or another data illustrated or maybe some kind of summary measures, partial data available to give more transparency to what actually has been done.
Yeah, I think that seems like a pretty fair assessment. It's certainly reasonable that if you are not able to provide your current data, that at the very least you could sort of either one provide them with a set of, for example, begin with a set of summary statistics, so it helps elucidate on the whole what the data is doing. And similarly, that if you provided a some type of simulation example so that people can actually see the algorithm in action and what type of mechanics you think are most pertinent. Obviously, it's not going to be the same as showing that it works on a real life data set, which has so many types of artifacts and anomalies in it that
Right.
it's hard to replicate those. But yeah, still, I mean, I think that seems like if you're going to not show, if you're not going to provide the data that you have, that what you've suggested seems to be a reasonable alternative to sort of giving a first order approximation of it.
Yeah, and I mean, there's also now a lot of research that's been done on trying to identify the data and even corrupt the data so it could be shared. And I think those are also perfectly acceptable things. But like for me, otherwise, and I mean, I'm distilling it down quite a bit and simplifying it, but essentially it boils down to, we have this amazing data that we're not going to show you on this amazing result that you cannot reproduce or verify in any shape or form except taking our words for it. And we want to publish a paper based on that. And I just I have an issue with that.
Yeah. I guess it depends for me. I guess I'm a little bit less bothered by that, just in the sense that well, one, I guess my baseline is pretty low where I don't generally trust any published paper. Like this is on words like basically anything.
Right?
Yeah. Well, it's because it's just like just from where I go, we're in a field which has, so many pilot studies, so many pilot algorithms that don't go anywhere in the future. And like, that's fine. People need to figure those things out. And you need to try a lot of things to make some things work. But I guess the reason that I read papers is out of interest for ideas for my own work. So as long as someone is saying something where it's like they describe reasonably what the actual sort of action mechanism between their algorithm and the data was, that's interesting enough to me that I'm willing to be like, yeah, I'm glad they saw that. And I don't care if it's on archive or it's on, IEEE or wherever. Those sort of things, maybe I'm just reading them more out of interest. But at the same time, I realize that the barrier for which I'm holding these papers is maybe a little bit lower than most people, where I'm just trying to see, will this stir up some ideas that I personally might enjoy or might be able to make use of, versus will this be replicated? Will this be reused?
Well, and I think there's several. First of all, like if there's another data set that is used in the same methods paper, then I don't think there is a huge issue that one of the data is private and you don't share it. Then, as we have discussed, you can have a simulated data or perturbed data in some way that you can share instead. And I think there's also a third option. If the data is sensitive, sometimes it's like sensitive now, but not like in 2 or 3 years. And I think that is also acceptable, because that means like eventually, I mean, if it's 20 years, maybe not so much, but if it's like 2 or 3 years, okay, right now, you collect this data, you really want to publish using this data, you don't want to share it to everyone because it took a lot of work to collect. But eventually you will release it. But right now people can already benefit from the initial studies that you have done. And I think that is also an acceptable point, because there is a point of release in the not so distant future where at least theoretically someone go back and see, was that actually done validly or invalidly? But I mean, otherwise, I feel like there is absolutely no accountability for what you present. I think that's where I personally have an issue with.
Yeah, and I'll be honest. Like, I've reviewed some papers that were clearly fraudulent. As in, like, where it was literally they absolutely 100% just made up the results because there's a misalignment between the algorithms that they're using and the metrics that they were actually presenting at the end, where it either they completely miswrote something, in which case that's on them too. But again, there was a complete logical disjunction. I'm not sure what it would be, just like disconnect between the algorithm that they're describing, the metric that should be generating, and the metric that they described and the values of those metrics at the time. And so it was actually, I might have stopped reviewing for that journal after they sent me that one, because like this one should not have even made it to the reviewers. But yeah, no, there's
Sure.
but it's I have no doubt it really seemed like it was the authors were just basically thinking, oh, they're not going to actually look at this too hard, and we're going to get a publication. And nope, I was there, and they made a mistake. Like this one, unfortunately, was like super in my wheelhouse. So it was like right where I knew exactly what to check for, because when someone does something in this area, I'm interested to know. So maybe they had the mistake of having a curious reviewer who's like, oh, maybe I can learn something from this. But yeah, no, I without a doubt, I know as a fact that there is fraudulent research out there, and I think that
I'm sure there is.
yeah.
But there's
Yeah. But yeah, and the solutions that you described are certainly ways that would relegate against doing that. But yeah, maybe that's a good place to stop. Unless you've brought us some silver linings. Do you have one more silver lining before we go?
one silver lining. Well, I think maybe I should summarize the silver lining, because it all sounds kind of depressing. But I think ultimately, if you spend time making your research reproducible, it increases the chance that others are going to actually use it. And choose your algorithm for comparison that are going to give you benefits in the long term, even if it doesn't give you benefits in the short term. And personally, a lot of times my students don't believe me when I first tell them that. But if you make your job, your research reproducible, you're not saving your time right now, but you're saving you tons of time later on. Whenever you do revisions, whenever you do extensions to the previous methods, whenever you analyze the same data set and slightly tweak the processing steps because the goal is different, you are essentially paying yourself for it, but making sure your analysis is reproducible, not to mention more replicable, have a higher chance of being replicable in the future, just doing plain good science.
Cool. Well, Irina, as always, I enjoy our conversations. I respect your research integrity and immensely, and I really respect the output of the research that you're doing. So I always enjoy our conversations, and I look forward to the next one when time allows. So thanks again.
Sounds good. Thank you for the opportunity.
Hey guys, it's Glenn. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. If you won't go totally crazy beyond that, forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed in the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.